Good morning. Guten Morgen. Yes, is this volume okay? Joyce, is this volume all right? I always ask my wife, Joyce, because, you know, she gives me one of these or one of these. Very pleased to be here today, and I want to thank Gerfried Stocker and Michael Shemaya for helping make this happen. Thank you. It's really a pleasure to be here with the future innovators. Innovation has been my life, actually. Innovation is unrelenting, non-ceasing. It never stops, and that's a good thing. Sometimes it's disruptive, which is also good. Sometimes it's gradual. It's good in any case. It's always challenging. It's always fun. I think innovation is a delightful thing to work on. However, it is often difficult. I worked at Kodak for 32 years, and my entire career was spent trying to get them into electronic imaging when they didn't want to go there. So I can feel your pain when you are working on innovations. My wife will tell you that I actually had hair when I started to do that. Okay, let's see. All right. Our topics for today and many more are in my new book. The title suggests some of the book's conclusions, and Gerfried will be pleased that both conclusions start with a C. Go figure, I mean. So the first one is you have to choose what business you're in. It could be, in this case of Kodak, electronic imaging or imaging, chemicals, or pharmaceuticals. The company tried to feed all three of these businesses at the same time, and as Michael Shemaya will reveal in his book, which is still in draft, resource allocation was an issue. The other thing you have to do is something that is due to one of my heroes, W. Edwards Deming, who wrote the 14 Points. Anybody ever heard of the 14 Points by Deming? I don't know. Anyway, point number one in his 14 points was constancy of purpose. That also starts with a C, Gerfried. So both choosing what business you're in and then having constancy of purpose and sticking to it are first two lessons. These are very important for a technical company, to be sure. However, the subtitle indicates that the tone of my book is positive despite the negative outcome of Kodak's bankruptcy. And in my opinion, the great technologies that Kodak helped invent, including today's topics, made our little planet a better place for us all to live in. So let me start with one of my first assignments and one of Kodak's early innovations in electronic imaging. This is a spacecraft that flew in the 60s called the Lunar Orbiter. It flew 5 successful missions in 1966 and 67, mapping the entire surface of the moon, both front and back, to prepare for the Apollo moon landing in 1969. Kodak designed and built the camera payload, and I worked on a portion of that. Let's see. This is the camera right here. And then we have 4 solar panels and a directional antenna for sending the pictures electronically back to Earth. This is an omnidirectional antenna for orienting the spacecraft. Didn't have to be pointed, it always worked. These are the sources of energy for the rocket, and that's the nozzle right there. So this is the entire Lunar Orbiter spacecraft. It had 2 lenses, a 24-inch lens for close-up imaging and a 9-inch lens for mapping. This complete spacecraft is hanging, looks just like this from the ceiling of the Smithsonian Institution in Washington. However, it looks to me like the engineering model. Here's a picture of the Lunar Orbiter at work. Of course, it's not an actual photograph. It could not be. Anyway, it's an artist's conception. It shows the orbiter at work with the lenses pointing down, and if you notice, the directional antenna is aimed at the Earth to send the pictures back. In the George Eastman house in Rochester, New York, which I invite you to come to someday, and I will give you a look around, they have one of these actual payloads. This is one. And it used inside of it, in these little rollers over to the side here, it used a predecessor of instant photography called bimat film. So it had real film coming in, getting imaged by the lens, and then a developer layer coming in and instantly processing the film, drying it, and then scanning out the film with a flying spot scanner, which is a little cathode ray thing. It went like this, and well, actually, it went like this, and scanned out the film and sent the images back to Earth. So it was a predecessor of instant photography in the 60s. I know it looks kind of clunky and old-fashioned today, but it was very high-tech 48 years ago. You know, it's hard to believe, really. Back then, there was no internet, there were no CCDs, no integrated circuits. Let's see. None of these here, iPhones. How did we do this thing? Well, I remember it was Frieden electronic calculators, slide rules, and lots of graph paper. There weren't any home computers yet, but we did have an IBM 1620, used punch cards and Fortran to calculate optical things and orbital mechanics. So it was a lovely first project. I was very, very privileged to be on it. Now, this picture was taken by the first lunar orbiter, and the little round ball in the background is us. Okay, this is the first picture of Earth taken from out there, and it's a historic picture. It hangs in the Smithsonian. And I think it's one of the greatest pictures ever taken, both technically and psychologically. I mean, our little planet really is round, you can see. So the Lunar Orbiter prepared the way for the successful Apollo missions in 1969. And then the next thing I got to work on was something that was very secret. You never heard of this, probably. It was only declassified in 2011, 3 years ago. It was called the Gambit program. The camera was built by Kodak. It was secret spy satellites. This program was so secret that it didn't exist on any government rosters. You couldn't find a budget. Many people, even in the CIA, didn't know about it. This first Gambit was called KH-7. The KH is a designator for these satellites, standing for keyhole, which I think is appropriate for a spy satellite. It had a 77-inch focal length lens, and it was rather large. It was 15 feet long and 5 feet in diameter. It had a re-entry vehicle. The film wound up in this re-entry vehicle and then was sent back down to Earth. So this thing was a lot bigger than the only cameras that you might be familiar with from Kodak, perhaps these things, called the Instamatic camera. It came out in the same year as the Gambit, but nobody knew about the Gambit, but everybody's heard about Instamatic. In those days, I think Instamatic was synonymous with camera. But it was a lot smaller than the Gambit, of course. In fact, there it is, to scale. For you geeks out there, love geeky things like me, the volume of this spacecraft is equal to 16,000 Instamatic cameras. Okay. My wife always wondered why I care about that. It's a geeky thing. I just like it. Okay, so then I got to work on something even more astounding called the Gambit 3. This had a 175-inch focal length lens, and now it's almost 30 feet long, so if you're keeping track, that's 32,000 Instamatics. And now it's got 2 reentry vehicles. These were phenomenal devices. I'll give you an idea of the mission really quickly. First you had to launch. It was launched from VAFB, which stands for Vandenberg Air Force Base, California. And I was out there as a young engineer monitoring telemetry for this thing. It was very exciting. I couldn't tell Joyce where I was going, though. It was very inconvenient, but it was secret. I couldn't tell her. She didn't know until 2011, when it was declassified in Washington, what I did in the 60s. So then the rocket goes up in the air, and there's operational intelligence shared. It takes pictures for, in this case, 60-day missions. Halfway through, 1 reentry vehicle was sent down. There's the reentry vehicle. There's a little parachute. Well, what happened then? This is what happened then. Believe it or not, Air Force planes caught this thing in the air before it hit the water. It's an astonishing thing. And then the reentry vehicle is brought back to Rochester, New York. The film was processed by something called the Bridgehead program. And the images, the film and the images sent to Washington for analysis. So when we went to Washington, Joyce and I saw this actual payload being demonstrated, the actual rocket. She was impressed that that's what I was doing in the 60s. I was impressed with how beautiful the rocket was and how clean all the parts looked. I mean, it looked like a new thing. But anyway, the important part of this program for everybody here, actually, is it helped keep us out of World War III during the Cold War. Our government was convinced that there was a big missile gap with Russia, which was incorrect. Well, there was a missile gap, but it was in the U.S.'s favor. So the hawks in our government weren't able to encourage the government to do a preemptive strike and start something that probably would still not be over. So that was a very important contribution, I think. Here's another Kodak product you may not have heard of. It's called the Ectoprint copier. It came out in 1975. It had high-quality solid area development, and it set the targets for image quality for copiers and duplicators that you enjoy today, for Xerox and everybody else. It's one of the first products anywhere to have an onboard microprocessor. If you're into microprocessors, it had an Intel 8008 in there. It's one of the very first ones. This was a great business for about 20 years, and then Kodak sold it to Danka in 1995. Now here's another thing you probably never heard about, or you might have. That's the first digital camera. It was invented by my friend Steve Sasson in the same lab I was in 1975. It weighed 8 pounds. It took 23 seconds to load one image digitally on an audio cassette tape on the right-hand side. Oh, and by the way, to impress you, it had a 100 pixel by 100 pixel monochrome CCD, okay? Huh? That's a big deal. 0.01 megapixels. I mean, it's ridiculous, I know, but it was the very first one. It was a skunkworks project, and there was no follow-through on it. Many Kodak managers hoped that everybody would forget about it. Steve had to build a playback unit also. We didn't have the electronics for that, so we built it on an an existing but flexible Motorola microprocessor development system. Here it is playing back one of our favorite test targets of the time, called the boy and dog picture. We use this a lot for things. Now, just to give you an idea how primitive things were back then, people, when Steve talks about this, they ask, do you have a print of the camera pictures? You know, he said, no, I don't have any prints. Why? There were no electronic printers then. So we had a CalComp pen plotter. Okay, it just had a little pen that moved around and made charts for our geeky reports and so on. And so a friend of mine named Ed Granger came up with an ingenious halftone algorithm based on how long the lines were to make an image of the boy and dog picture on the CalComp pen plotter. This is the first time in my life I ever saw a digital print. And we thought it was great in 1976. I know it looks pretty crude today. That's the other thing about innovation. It's like, in the beginning, it's too big, it costs too much, it's not good enough. All those negative things people can say about your innovation, it goes with the program, okay? It gets better. About the time the camera was being invented, Bryce Beyer in the research lab, is another fellow I knew, invented the color filter array. So the previous CCD was a monochrome or black and white. CCDs are inherently black and white devices. In fact, they're analog devices. Anyway, by putting the color filter array on in this configuration, Bryce Beyer figured out the way to make the CCD see color. So now the disruptive technology begins, because now not just electronic imaging, but color. Electronic imaging is coming. You know, again, I have to reach in my pocket for my iPhone. This thing has not one, but two Beyer arrays inside. There's a front and rear camera on this. An 8 megapixel rear camera and a 1.2 megapixel front camera for video conferencing, right? And so Bryce's invention is still with us today. It's in many of your pockets and purses right now. Another thing you never heard of is this little guy here. This is about this big, a little portable inkjet printer. We built with something at Kodak called Diconics, which wound up reporting to me later in my life. This is the world's first portable inkjet printer. And it was very cute. It was built off of the technology that they developed for high-speed inkjet printing. And they had something called the Digit that ran at 1,000 feet per minute and made variable data. Again, this was pretty early on for variable data digital printing. The Digit and this technology were the forerunners of today's Prosper presses that Codex sells today. I'll show you one of those at the end. Work was continuing in the research labs to get past 0.01 megapixels and evolving up to 1.4 megapixels. We call it the first megapixel sensor in 1986. Took it to Photokina. It was a very big hit, and it was the very first one of these things. And the 1.4 megapixels, by the way, was not an accident at all. It was designed that way. Research asked me, how big should it be? And I said, well, we have a thermal printer that makes a beautiful 5x7 print using 200 DPI technology. So if you do your math, 5 times 7 times 200 times 200, you get 1.4 million. And so this sensor was designed to work with that. So innovation marches on, and now we have something called the Codex still video floppy disk in the 80s. We built an entire imaging system off of this thing. It could hold up to 50 still video images in 50 circular magnetic tracks. This was the system, comprised of many parts. I'll just indicate a couple of them. This is a very nice thermal video printer. It made beautiful 4x5 color prints. And this thing in here, it's called the transceiver. Now this thing, again, you're before the internet, so this could send a color, high-quality picture over phone lines, standard phone lines, in under 60 seconds back then. That was a great innovation, and it won an Emmy Award in 1989 because if you remember the Tiananmen Square incident with the fellow with his hands up in front of the tank, that picture got sent to New York with this little box here. They call it at CBS the magic box. And inside it, for the techies here, it used discrete cosine transform and Huffman coding. If you're not sure what that means, it's the technology behind what you now know today as JPEG. So this thing had JPEG in it 2 years before there was JPEG out there. And so every day you use this innovation that Kodak helped develop called JPEG for picture compression. All right. I'll show you a little innovation track here for thermal printers. The first one you saw was the 4x5 printer. Makes little prints like this. We had big demand right away for larger format printing. So we came out with the XL 7500, we call it, 7700, which made 11 by 11 inch prints for military applications. That's why it looks rack-mounted, industrial strength, ugly but very beautiful printer. And here's some follow-on innovations. Okay. Up here is a follow-on printer we call the Koala, code name. It was a smaller than this. It was higher resolution. It was lower cost. It was better all the way around. That's a gradual innovation. And then the insides of this thing got put in these kiosks. These are all over the world today. There's 100,000 kiosks out there that we developed to make prints from. You could scan your prints in, or you could use a computer chip, right, or bring a CD to the kiosk and make prints. That's a very nice product. It was spun off about a year ago during the bankruptcy as Kodak Alaris, but exists today. Well, here's the world's first digital single-lens reflex camera. It was called the Tactical Camera, designed by Jim McGarvey at Kodak, for military applications. This is also at the George Eastman House. It's a little clumsy, you can tell, but it's built on a Nikon back, and it has, you had to carry this over your shoulder. It was a little heavy, but it stored the images very nicely. All single-lens reflex digital cameras today descend from, this is the grandfather of them. Because using the still video floppy magnetic disc didn't make prints that were as good as we knew they could be if they were digital, we invented a digital format for storing the pictures called photo CD. This is what we call a hybrid product back then. It combined traditional film capture and electronic imaging to give our customers the best of both worlds. Oops. I didn't mean to go there yet, but okay. Anyway, the photo CD was intended by us to be a commercial product. Here's another innovation trap for you. It was mistakenly, I believe, launched as a consumer product due to egos in the marketing department, but it should have been launched as a commercial product first. Now, Steve Jobs and Apple wanted to make an impact on electronic imaging back then, and so this was a product came out called the Apple QuickTake, 1994. It was referred to as a computer camera. It could take 8 640 by 480 pixel pictures. At $750 retail, it appealed to a lot of early adopters. Most people don't know that it was designed and built by Kodak because there's no Kodak logo on the product, just the Apple logo. by design. I could do a whole talk on electronic cameras. I'm only going to show one more. One I happen to like myself for a funny reason. This particular camera had an OLED display in it. That means organic LEDs. And that's the new future of display technology in the world. Kodak invented OLED technology and sold it to LG of Korea in 2009. That one actually killed me because I know that's so important to the future of displays that they should sell this technology, but I was retired by then and I couldn't help it. But if you haven't seen an organic LED large format display yet, you're in for a real treat. These babies, when you turn a pixel off on an organic LED, it's really black, so you get high contrast, beautiful saturated color, resolution, it's high speed, and you're going to love it. Currently, Kodak, what remains of it, is selling amongst other things, the Prosper inkjet presses, very high speed, beautiful color, digital, data on demand printing. They can do your custom print on demand books and that sort of thing. This press is, by the way, rather large. This little box here is a desk. So that's a big printer. And if you have a million euros in your purse, you can have one of your very own. A little story behind this one. In 1983, Kodak bought from Meade Imaging this inkjet technology and called it Diconics. Then it worked for me for a while, and I told them that this technology I thought was so important that they should keep working on it and getting it into color, higher resolution, higher quality, fast, lower cost, all of that. They were working on all of this stuff. After I left, Kodak sold Diconics to Cytex, a company in Israel, and it became Cytex Digital Printing Incorporated. Another thing that gave me a big headache, later on, Kodak changed its mind and bought it back from Cytex and called it Versamark, and is now the place where this technology comes from. Well, so that's a perfect example, Gurfried, of the constancy of purpose problem that I mentioned earlier. All right, now I'm going to wrap up my little short talk today with an unknown story about the Hubble Space Telescope. This is a beautiful thing. The Hubble is world famous. It's still in service. It's taking gorgeous pictures of the universe for everybody to enjoy. The optics was originally designed by Perkin-Elmer, but the primary mirror in this satellite was incorrectly ground and polished and had excessive spherical aberration. This picture of the Hubble was taken from the space shuttle Atlantis as it departed the Hubble after a service mission. You can see here, that's a lens cap. It's up so it's ready to take pictures. Now, what people didn't know is, as a backup to the Perkin-Elmer mirror, Kodak built the mirror as because a project like this, you can't have the whole entire program in series with one mirror. You've got to have a backup in case something happens. So somebody drops a wrench on it and breaks the mirror. I mean, so Kodak had a backup mirror. Now this thing is not a little thing. You can't tell the scale here, but it's 8 feet in diameter. So this is a big mirror. You can see the honeycomb structure of the base through, because there's no reflective coating on this mirror yet. This is now in the Smithsonian, but it was never utilized because the mirror with spherical aberration was what was sent up. Now Kodak helped NASA figure out what was wrong with the Hubble and how to fix it. So Here's a picture of what they call spiral galaxy M100, taken before the optical repair. These are the first pictures the Hubble sent back, and everybody was dismayed because they were blurry. You may remember that. And it was a terrible issue. And then Lou Allen, who headed the Jet Propulsion Labs for NASA, formed a committee, and Chuck Spoolhoff from Kodak, one of my mentors, was on that. And they figured out that during the testing, there was one little optical element in the testing by Perkin-Elmer was out of place by 1.3 millimeters, and that caused the spherical aberration. Okay. So what do you do about it? They figured out 2 polished mirrors, one with the little curvature in it, that they sent up with the astronauts and inserted into the optical path to, just like my glasses, to correct the vision of the Hubble and make it better. These astronauts, by the way, had to learn to use dozens of new tools to do this job with their gloves on, but they did it. And then this is after the servicing mission. Now the spiral galaxy looks better, about 10 times better resolution. So Kodak helped get new spectacles for the Hubble Space Telescope. This is another one of my favorite pictures of all time. The Horsehead Nebula. This is 1,500 light years away. And if you were to view it with your naked eye, you wouldn't see anything because all of the stuff you see in color here is in the far infrared. The deepest infrared your eyeballs can see is 0.75 microns, right? In this picture, the 1.1 microns is colored in blue, and deeper red, 1.6 microns, is colored in red. So it's what they call a false color image. But nevertheless, it's very beautiful. It shows this nebula, which is, of course, the birthplace of stars. And it's the sort of thing that the Hubble is famous for. So let me just say in closing, while you continue to marvel at this beautiful picture, I hope you enjoyed this rapid look at some of the many great technologies Kodak has developed, which I think makes our little planet a little bit better for us all. Thank you.